Sorry guys, this girl losing her voice needed a quick hydration break, but we are going to dive right back into this. So two polygons are similar, so we know that is out of the water. We are done. They're similar, we just need to find x and y. In order to do that, we need to find their similarity ratio though. So we know that s is congruent to n, m is congruent to r, and t is congruent to p. So looking at our sides, s and r goes with n and m. So looking at those as a ratio, we have SR over NM, which is 32 over 16. So that means this reduces down to, these are both divisible by 4, gives you 8 over 4, oh, 1/2, duh. There, 2 over 1. So 2 over 1 is our similarity ratio. So in order to find x and y, we're going to set our unknown pieces up to that similarity ratio. So RT and MP belong together. So RT over MP is 38 over y. So I'm going to set this equal to 2 over 1 and then cross multiply and solve for y. So that gives us 38 is equal to 2y. Divide by 2. And that gives you that y is 19. And we're going to do the same thing for ST to find x. So ST is belonging to MP. ST is x over MP, which is 13. We're going to set this equal to 2 over 1. We have the big triangle over the small triangle, and then cross multiply. And it looks like x, I wanted green, x is going to be equal to 26. Okay? So our similarity statement here is going to say triangle STR is similar to triangle NPM. Awesome. Good job, guys. So we're going to look at a similar problem. So these two triangles are similar. If you want to name the corners, you can. You don't have to. It might just be helpful to color code them. So again, having highlighters or colored pencils would be super beneficial here. So it says, what is the length of the side in the big triangle that corresponds with the side length 8 in the small triangle? So looking at where 8 is on the small triangle, it is touching our single hash mark angle. And what looks to be a right angle, we can't say it's a right angle, but it's touching what looks to be the right angle. So that side is going to correspond with the side that has the one angle marked. And so 8 corresponds to 12, so 8. So 12 is our answer. 12 is the length of the long side. And then it says, what is the length of the side in the big triangle that corresponds with the side length 10? So 10 is right here. And that corresponds, if this was a right triangle, it looks like the hypotenuse, but it is the one that touches the two angles that are marked as congruent. So on the big triangle, again, that's this side. But there's no length associated with it. I don't know. No length given. But we know which side it belongs to, so that's good. And then what is the length of the side in the big triangle that corresponds with the side length x in the small triangle? Let's see, x is over here, and it touches the double marked angle. The double marked angle. And so it's going to belong over here to angle to side 9. So we're just matching up the angles and the sides that belong together. The angles are always congruent, but the sides are not. They're just similar to each other. All right, let's try one more. This one's set up really nicely. It tells you everything you need to be looking for. So we have two angles that are marked as congruent. We have angle C is going to be congruent to angle R. And then we have angle P is congruent to angle T. Okay, so looking at that, SB, this side over here with 2, is going to correspond with JH. Okay? They're on the opposite side of where those red and green angles are marked. And then we have which side corresponds to BP. So BP is along the side here. It touches B and P. It touches the green marked angle, so the single marked angle, so that's going to correspond to HT. Now, it's kind of obvious here because those are the only ones with given information, but it's not always going to be like that. Sometimes all of them will have information and it will be misleading. So just make sure you match up which angles you're talking about in order to have all the complete information. So this proportion is set up as SB over, it's everything from the small shape, so SB over BP, it's all from the small polygon, over the matching sides from the big polygon, JH, over HT. That's how this proportion is set up. So we have SB, which is 2, over BP, which is x plus 3. So everything from the small polygon. And then everything from the large polygon is going to go here. So from the large polygon, SB corresponds to JH, which is a 3, and HT, which says 2x plus 2. So now we've set this up to cross multiply to solve for x. Get rid of these black boxes and cross multiply. Go this way and this way. So remember, use your parentheses. So 2 times 2x plus 2, we're going to have to distribute there, times 3 times x plus 3. Again, distribute there as well. So you're going to have 4x plus 4 equals 3x plus 9. We're going to do some moving around. Subtract your 3x, subtract your 4. And you end up with x equals 5. There you go.